Good morning. In this video session, I would like to give the equations of kinematics. Velocity v is ds by dt. That means differentiation of displacement with respect to time gives the velocity. Acceleration a is equal to dv by dt, means differentiating velocity with respect to time, and v is nothing but ds by dt, that is equal to d square s by dt square. So if you observe, s is a equation in terms of time, v is a equation in terms of time, so we can say the displacement s is equal to integral v dt plus constant. If you integrate velocity, that means the velocity is given here. If you integrate velocity with time and add in some constant, you will get the displacement. Similar way, velocity is integral a acceleration dt plus c. And this s can also be given as integral v dt plus c or you can say integrating 2 times, acceleration integrating 2 times plus c1t plus c2. So these are all kinematic equations of a particle when that particle is having an equation in terms of time. So this is linear kinematics. This is a linear kinematics. Okay. If you consider angular kinematics, we have angular displacement. Angular displacement, you can say this as a theta, angular displacement theta, that means number of revolutions. Angular velocity omega, angular velocity omega, and angular acceleration alpha. So omega is equal to d theta by dt, or theta is equal to integral omega dt plus c. Similarly, alpha is equal to d omega by dt plus d squared which is equal to t squared theta by dt squared. Theta is equal to double integral alpha dt plus c1t plus c2. So S is a linear displacement, V is a linear velocity, acceleration is linear acceleration, theta is angular displacement, omega is angular velocity, and alpha is angular acceleration. So these are all called equations of kinematics. Now we'll see what is how the graphical representation of these equations are. So you see a graph between time and displacement. A graph between time and velocity. A graph between time and acceleration. Okay, so say for example, velocity is equal to 6t square plus 3t plus 4. This is the equation. So what is the displacement at time t is equal to 5 seconds? At time t is equal to 5 seconds, b is equal to 12t. That means I'm differentiating this equation plus 3 plus 0. That means 5 seconds, t is equal to 5 seconds. 12 and 60. 60 meters per second. Okay. So in further video sessions, we'll take up some equations and try to find out what are the values of, how to find out the values of the kinematic parameters such as velocity, acceleration, and displacement. And we are saying this is as a kinematics because these three parameters are interrelated, or three variables are interrelated, and in these kinematics, we don't see anywhere the cause of motion. Okay, so this is what I would like to explain about the kinematic parameters and its equations in the topic of kinematics. Thank you for watching the video.